welcome to Two Projects. In this video, we are going to explain about the project which is Intelligent Ultrasound Imaging for Enhanced Breast Cancer Diagnosis, Ensemble Transfer Learning Strategies. Before getting into the execution, first let us understand what is the project about. Breast cancer is one of the most common cancer worldwide, with over 2.26 million new cases diagnosed each year. Even though treatments have improved over time and more people are surviving, it remains one of the top causes of cancer related deaths. This makes it crucial to detect the disease early so that treatment can be more effective and the chances of survival increase. Currently, there are two main ways to detect breast cancer. One is mammograms and the other one is ultrasound. Mammograms are special x rays of the breast. While these methods have helped many women, they aren't perfect. For example, mammograms can be less accurate for women with dense breast tissue because dense tissue can make it harder to spot tumors. Moving on to the ultrasounds, on the other hand, is good tool but can be very dependent on the technician's skills. If the technician doesn't spot something, it might get missed. Also, ultrasound results can vary depending on how the images are taken. So sometimes it is not as reliable as we need it to be. This is why there is such a strong need for better and more accurate methods to detect breast cancer, ones that can overcome these challenges and give doctors more confidence in the diagnosis. Here, where artificial comes into the picture, especially deep learning. So, deep learning models like convolutional neural networks, so deep learning models like convolutional neural network is becoming a game changer in medical imaging. For breast cancer detection, these AI models can look at ultrasound images and accurately spot cancerous areas. This helps doctors detect cancer earlier and reduce the chance of false positives, where non cancerous area is mistakenly identified as cancerous. However, there are few challenges. First, these models need a lot of data to train onto accurate. So, second, it is important that AI can explain its decisions so doctors can trust and understand it. Lastly, integrating these AI tools into everyday medical practice takes time and effort. Solving these challenges is key to making AI a reliable and effective tool in improving breast cancer diagnosis. So, to overcome all these issues, this project's aim is to improve the breast cancer image analysis using advanced technologies using transfer learning. So, this project's aim is to improve the breast cancer image analysis by using the transfer learning techniques and also the machine learning techniques. Here we start by collecting the data. We do basic pre-processing. After that, we take ultrasound images into the picture and we do some basic augmentation and also we normalize the data. Next state of the art models that are transfer learning models that are Inception V3, VGG19, VGG16 are fine tuned to extract key features from the images. These models helps to identify important patterns that are crucial for diagnosis. So the system then uses ensemble machine learning models. Then we use some ensemble models which combine predictions from different machine learning models such as MLP, that is multi-layer perceptron, with varying layer structures of 10 is to 10, 20 by 20, and 30 by 30. And also the support vector machine. So we use support vector machine with different kernels, RBF, and polynomial. So this technique enhances the system's accuracy by considering multiple viewpoints. Finally, the system performance is evaluated by using metrics that are accuracy, precision, recall, and FN score. So we will be using MLP and support vector machines to process the features, and then we will be evaluating all the models using this accuracy, precision, recall, and FN score. Moving on to the extension of this project. To further improve the performance, we have incorporated exception model for classification of the breast cancer, which is another powerful deep learning model to improve the analysis of breast cancer images. The system now uses exception alongside with other machine learning algorithms to make even more accurate predictions from the data. In addition, we also have integrated YOLO models, that is, you only look once family of models, that is well-known algorithm in image processing that's a great at quickly detecting objects in images. Furtherly, we also have built front end using Flask framework. So we have used Flask framework to build the front end. This allows users to test the system through a user-friendly interface to ensure that only authorized people can access the system. And we also have added authentication features which provide secure login and protect sensitive information. Moving on to implementation of the project, we have followed the steps in the flow of work. As we have done classification and detection, we have followed two different steps. So for the classification, first, what we have done is we have imported the necessary libraries for processing and training the models. And then we analyze the ultrasound data set to understand the structure and contents. Then we have done some image pre-processing where we have rescaled the image. That means we have normalized the image pixel values. We apply shear transformations that are minor shifts to the image of augmentation, and we randomly zoom into the image to make the model more robust, and we add horizontal flip. That means we flip the image horizontally. By that we can add variations, that is image variations, for the training purpose, and we adjust image size for model compatibility. So this is by using image data generator. Now coming to the feature extraction using CNN and HOG, here we extract features using CNN and HOG models. And then we load the data, we resize the image, we convert image to from BGR to RGB, and then we combine the images and also the labels, and we convert all the images to NumPy arrays. And coming to defining early stopping, here we implement early stopping to avoid overfitting or underfitting during training. And then we load pre-trained models and also set up the model architecture. Then the trained data set is used to train the models so that they will be able to detect that is classify the breast cancer. And the best performing model will be selected for the future classification. So this is for classification of the breast cancer. Moving on to the detection part, similar to classification, we also load libraries for detection. And then we explore the data set where we load the images to be processed and visualize the image to understand its content. And next, what we do is we convert image to blob format. So here we transform the image into a format that is suitable for YOLO. And we set up class categories for the detection. And we define the region of interest in the image. And we convert images to NumPy arrays for further processing. And then we load pre-trained models where here we load the YOLO network layers for detection, and we extract layers that give the final detection output. Coming to next step, that is image processing, here we combine images with their annotations. And then we change the image to color format, that is from BGR to RGB, and we create masks for detecting regions of interest. And we resize those images to match the model's input requirements. The next step we do basic data augmentation where we apply randomness to the image, that is random transformations to the image. And we rotate the images to increase diversity, and we apply transformations for training robustness. Moving on, we install the packages that are required for the YOLO, and we prepare data specifically for the YOLO detection task. And we set up the YOLO models for object detection. We train it with the model that we train the YOLO model with the prepared data set, and then the best performing YOLO version will be used for future detection. This is for the detection part. Now coming to the front end part, we have created Flash framework. We have used Flash framework for creating the front end of the application. And then users, they will be able to upload the images in the front end for also classification and also the detection. That image will be processed at the back end. It will be fed with the trained model for classification and detection. Finally, in the front end, we will be able to see if it is classification or detection. So this is all of how we implement the project. Now moving on to the algorithms used. Here, these are the algorithms used for classification of the breast cancer. So we have built Inception V3 from the features extracted using MLP with all the following layers, and also with the SVM with the kernels of RBF and polynomial. Similarly, we have built VGG16, VGG19, exception, which is the extension model, and exception we have built with all this feature extracted values. Moving on to the extension detection part, these are the algorithms, these are the YOLO versions used for detecting the breast cancer. Moving on to the requirements, to implement this project, we need basic hardware and software requirements. So coming to hardware requirements, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let's execute the project. To execute, we need to open the code folder which contains source code files. So let us open the code folder of the project. So these are the source code files in the code folder of the project. Let us understand each of them, how will they be used in the project. So here in the first four folders, we have the dataset that is used in the project to train the models for classification and also for the detection. The images which are in this folder are used for classification, and the images which are in these three folders are used for detection part. So let us open this folder first. Here we have three subfolders. One is train, test, and validation. Let us open the folder train. Here we have three classes of the breast cancer where benign, malignant, and normal. Benign means person has cancerous tissues, but that will not spread. Coming to malignant, here person has breast cancer tissues that will spread and it is very danger. Normal means person don't have breast cancer tissues. Let us open the benign folder. So these are the ultrasound images that will be used for training the models. Get back. Here we have malignant images. So these are the malignant ultrasound images. And here we have normal ultrasound images where person has no breast cancer. Similarly, we will be having in the test folder and also the validation folder. Train folder is to train the models, and validation and test folder are to evaluate how the train model works. Let's get back. Coming to this breast cancer YOLO V5 folder, let's open that. Here we have two subfolders. One is train and the other one is test. Let us open the train folder. Here we have two more subfolders. One is images and the other one is labels. Let us open the images folder. So here we have total 623 ultrasound images. So these we will be using to train the YOLO models to detect the breast cancer. Coming to the labels folder, here we have files containing annotations or labels for objects in the corresponding images. So here each label file corresponds to an image file in the image folder. For example, this label file corresponds to the first image in the train folder. So accordingly, second image is correspondent to second label file. Accordingly, for all the 623 images, we have 623 label files. These label files, they follow the YOLO format. For example, let us open this first file. Here, this line represents a detected object. 0 is the class index, object class index, and this is the followed by its bounding box coordinates. This is X limit, this is the Y limit, this is height, and this is the width. Similarly, we will be having in all the 623 label files. Let's get back. Same we will be having in the test folder. So here you can see there are images and labels, right? So train is used to train the models and test is used to evaluate the models. Similarly, same images will be having in the YOLO V8 and YOLO V9 folder, but they are annotated differently because each folder contains same images, but they are annotated differently because each YOLO version requires its own specific type of image annotations for training and testing the models effectively. Having separate folders keeps the dataset organized, ensuring that each YOLO version receives the correct annotations it needs to function properly. So this is about the dataset. These three folders are for detection and this for classification. And in the sample folder, we have test cases for in the front end for detecting and classification of the breast cancer. Coming to static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Coming to templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have model files. So these are the model files which contain the algorithm information. This will be loaded into the project code during runtime. And here we have two notebook files which are the Jupyter Notebook files, which contain combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. In the classification Jupyter source file, we train the algorithms for the classification purpose. And in the detection, we will be training the YOLO models for the detection of breast cancer. And this is the signup.db file. This file is a database file which is used to store the user information. Now it's time for execution. So copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. So it has been opened. Now give the command cd followed by the space, paste the copied path. Now click on enter. So by giving this command, current directory will change to the code folders path, and here you can observe that. Now let's compile app.py file by giving the python space app.py command. Now click on enter. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So it is taking a bit of time. Just wait for a while. So here we got the link. This is the local host and this is the port. Now we have to copy the local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome. So I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. Let's sign up first. So click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on click here. Here we need to provide username and the password. Click on login. We have logged in successfully and we are redirected to classification and detection page of the project. If you click on classification, we will be able to do the classification of breast cancer. And if you click on detection, we will be able to do the detection of breast cancer. So let's do classification first. So click on classification. Here you can see a choose file button, right? We need to click on that for uploading the images. So let's click on that. So let's open the sample folder. Here we have two subfolders. One is classification and detection. As we're doing classification, let's open the classification folder. Now let's upload the images of benign. Let's open the benign folder and now check whether the application will correctly predict the breast cancer as benign or not. So let's open this image, click on open and now upload it. So the image will be processed at the backend and then we will be getting the prediction. So this is the uploaded image and here we got the prediction as the patient is diagnosed with benign breast cancer in ultrasound image. So from the ultrasound image here we got the prediction as benign breast cancer, which means that person has breast cancer tissues, breast cancer cells, but that will not spread and that are not harmful. Let's try uploading some more benign images and see whether the application will correctly classify them as benign or not. Click on choose file. Let's upload this image. Click on open and now upload it. So this is the uploaded image and here we got the correct prediction as benign breast cancer. Let us upload some more. Click on choose file. So let us upload this image. Click on open. And here we got the prediction as benign breast cancer. Now let's check with the other case of malignant. Choose file. Open the malignant folder. So now let's check whether the application will correctly predict the malignant images as malignant or not. Let us upload this ultrasound image. Click on open and now upload it. So this is the breast cancer ultrasound image that we have uploaded. And here we got the prediction as malignant breast cancer found in the ultrasound image. So this means that there are tissues of breast cancer found in that and that are very harmful. That means they will spread and they will harm the body. Let's try uploading some more images of malignant class. So let us upload this image. Click on open and now upload it. So this is the uploaded image. And here we got the prediction as malignant breast cancer found in the ultrasound image. Let's try with some more images of malignant class only. So let us upload this image. So the image has been pre-processed at the backend and trained model gave the prediction that there is breast cancer, that too it is a malignant breast cancer found in the ultrasound image. Now let's try with one more image. Click on choose file. Let us upload this image. Click on open and now upload it. So this is the uploaded image and here we got the prediction as malignant breast cancer in ultrasound image. Now let's check with the normal class. So click on choose file. The last class of breast cancer. So this is the last class where these are the test cases. So let's open this image. Click on upload. And this is the uploaded image. And here we got the prediction as patient is not diagnosed with breast cancer. Normal means that patient has no breast cancer. So this is the image that we have uploaded. And here we have the prediction that patient has no breast cancer. Let's try uploading some more. Let us upload this image. Click on open. And here, this is the uploaded one. And here we got the prediction. Now let's go for the detection. Click on detection. Click on choose file to upload the images. Now we have to open the detection folder. Click on detection. So let us upload the first image. Click on open and now upload it. So from the uploaded image and here benign has been detected. So here is where the tissue is, that is the breast cancer tissue, and here it is drawn. I mean benign bounding box is drawn around it. Bounding box is drawn around the breast cancer tissue and it has labeled it as benign because it will not spread. And here we have the probability score of 0.88. It means that it is how confident in detecting this benign breast cancer. Let's try uploading some more images. Let us upload this image. Click on open and now upload it. And here we can observe that there are two benign tissues found, that is benign breast cancer tissues found. So it has been drawn in the bounding box. Let us upload one more. Now let's upload this one. Click on upload. And here two tissues have been found, that is two breast cancer tissues, that too they are of benign type. Let's upload the other images. Now let's upload this image. Click on open and now upload. So here where the breast cancer tissue is there, a bounding box is drawn around that with the blue color, that is sea blue color, and it has been labeled as malignant with the 0.67 probability score. Let's upload some more images. Let's click on choose file. And now let us upload this image. Click on open and now upload it. And here two tissues have been found of breast cancer, and that too they are of malignant type, which is very serious. Let's get back. Let's upload some more. Let's upload this image. So here is the tissue of breast cancer. These are the cells of breast cancer and a bounding box is drawn around it. Let's get back. Click on choose file. And now let's upload this image. Click on open. Click on upload. Here there is no breast cancer tissues found, so that is why it is detected as normal with the 0.89 probability score. And a white line is drawn around the ultrasound image with the normal class label. Get back. Let's upload one more. Click on choose file. So now let's upload this image. Click on open and now upload it. And here, this is the breast cancer tissue and it is benign type. Let's get back. Click on choose file. Let's upload this one. Click on open and now click on upload. Here, benign has been found. That is benign breast cancer tissue has been found. So now let's know the difference between what classification and benign is. Sorry, detection is. So classification is just looking at the picture and deciding what it is. So when we did classification, we just uploaded the picture and we got the assumption that it belongs to which type of breast cancer. And coming to this detection part, when we uploaded the image, here it is particularly focusing on where that breast cancer tissue is. So here bounding box is drawn around it. So it will locate that where is that object from the uploaded image. So you got the difference, right? Now let's get back. Now let's check with the graphs. Click on graph. So here first we have the classification graph where this is the accuracy, precision, recall and F1 score graphs. So these are the metrics used to evaluate all the classification models. These are the models used to build the classification. I mean, these are the models used to train the data so that they can do the classification. Here on x-axis, we have accuracy score and on y-axis, we have algorithm names. Similarly, this is the precision comparison graph. This is the recall and this is F1 score. If you observe, extension model is having the highest accuracy, highest precision, highest recall, and also the highest FN score. And here we have for feature selection. Here, these are the models that are individually built on the dataset, and here we have trained all the algorithms after extracting features with MLP as well as SVM. So here you can observe that exception model is built with the SVM and also with the MLP and also with the voting classifier and decision tree. Similarly, we have built VGG16 with SVM and also the MLP extracted features. And this is the precision score comparison graph, this is the recall score, and this is the FN score. Coming to the detection comparison graphs, so this is the confusion matrix where on x-axis we have the true labels and on y-axis we have the predicted labels. This is the FN score comparison graph. Sorry, this is the F1 confidence curve graph where on x-axis we have the confidence level and on y-axis we have the FN score. Similarly, here we have precision recall curve graph, and this is the precision comparison graph. This is the recall. This is FN score. Here, these are the models used to train the data set so that we will be able to do the detection of breast cancer. Here we have recall and MAP. MAP, precision, and recall, they are the error metrics used to evaluate the detection models. So now let's click on sign out. In this way, just by uploading ultrasound images to the system, the trained models they will be able to classify and also detect whether it is malignant type or it is benign type. If there is no breast cancer, it will detect as normal. So this will help the doctors and also the patients to diagnose early. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.